All right, Rishi, looks like you want help with numbers 9, 11, and 12. So, first we want 2 in each of them, or in 9 at least. Let's factor the top. So I've got 2x and x, and let's see, we need things to multiply to get 10. So if we go 5 and 2, we got to get 9 in the middle there, right? So if we went 5 and 2 and plus 5 and plus 2, looks like the top is factored. The bottom is going to factor into x minus 4 times x plus 1. Okay, so when you graph them, first thing you want to start with, I think, are the asymptotes. So we have a vertical asymptote at x equals 4 and x equals negative 1. So I'll write those here and put those on the graph. So there is one vertical asymptote and one at negative 1. And the horizontal asymptotes, we look at the degrees. They are both second degree, meaning they're equal. So we do the leading coefficients, which is 2 over 1. So we have a horizontal asymptote at y equals 2 over 1. So that is going to be here. So that is our first step, is to put the asymptotes in there. Then we will do the intercepts. X-intercepts are whatever make the top equal to 0. So when x is negative 5 halves or negative 2, so my x-intercepts are at negative 5 halves, 0, and it was negative 2, 0. So negative 5 halves is like negative 2.5. And negative 2, 0, oh, that's right here. All right, and we have y-intercept. We plug in a 0 for x, and it's typically easiest to put that in here because that both becomes 0, that both becomes 0, and we're left with 10 over negative 4, which is negative 5 halves. So that's 0, negative 5 halves for our y-intercept. That's at 0, negative 2.5. So, and holes there are none because nothing canceled out. So now we want to graph this on the right side. It's either going to be on top or on the bottom. And I could check what happens close to the asymptote, but it must be on top because if it was on the bottom, it would have to hit the y-axis, and I know there's no y-intercepts over there. In the middle, I'm going to plug in 3.9, so something really close to that vertical asymptote to see if the graph is up here or if it is down here. So if I plug in 3.9 and for x, this is positive. 3.9 plus 2 is positive. 3.9 minus 4 is negative. And 3.9 plus 1 is positive. So when I do all of that, I would end up with a negative. So at 3.9, the graph is negative, meaning it is down here. So now I don't know if it goes up and comes back down, or if it goes up and heads through. So I could plug in negative. This is at negative 1. So I could plug in negative 0.9. If I plug in negative 0.9, that's positive. That's positive. Negative 0.9 minus 4 is negative. And negative 0.9 plus 1 is positive. Therefore, the whole thing is negative. So at negative 0.9, it is also negative, which means the graph must come up, go through that intercept, and come back down. And actually, that makes sense because we don't have any x-intercepts, right? It'd have to go through the x-axis if it went up here. All right, now on the other side, on this left side here, I could plug in negative 1.1, so something just to the left, again, of this vertical asymptote. So if I plug in negative 1.1, that is going to be positive. That is going to be positive. That is negative. That is negative. Therefore, the whole thing is positive. So this is positive here. So this is an odd looking graph because I also have these intercepts. I have this horizontal asymptote. So the graph comes down here, hits the intercept, hits another intercept, and then heads off to the left. So that will be it for number 9. Number 11, what are we doing here? We are writing our own function. And so when we do that, we have a horizontal asymptote at y equals -5. So that's going to be here. I'll just draw that in so we get a look. Vertical asymptote at x equals -4 and x equals 6. So at -4 is here, 6 is here. X-intercept is at -1, 0. So here is an x-intercept. All right, so lots of things. There are different possibilities for this graph. But let's deal with first, I think, easiest, the vertical asymptotes. If the vertical asymptotes are there, that means the denominator must be x plus 4 because of this guy, and x minus 6 because of this guy. That would produce your vertical asymptotes at -4 and 6. We also know this has a horizontal asymptote at y equals -5. So that means that the degree of the top and the degree of the bottom have to be the same. So since the bottom is x squared, the top must be an x squared, or second degree, but our leading coefficients must be -5/1. Now our x-intercept is at -1, 0 only. So that right now, the way I have this written doesn't work because remember an x-intercept is whatever makes the top equal to 0. So what I need to do is kind of adjust this. If I did an x plus 1 squared, then that would have an x-intercept at -1. We still have x squared on top and x squared on the bottom. So I have my horizontal asymptote at y equals -5. I have my vertical asymptotes at -4 and 6. No holes because none of the factors canceled out. And so that could be our equation. I guess it asks us to write it as f of x. So I would say f of x equals that. For problem number 2, same thing. Start with the vertical asymptote. So if you have a vertical asymptote at x equals 2, then that means the bottom is going to be x minus 2. And if the horizontal asymptote is y equals 0, that means it should be bottom heavy. So I now have it bottom heavy. No x-intercept. So what I have works because nothing makes the top equal to 0. And now the last part, though, it says 2 holes. One of them being on the y-axis. So if it was on the y-axis, we could do this. And if I did that, those would cancel, creating a hole. And they would create a hole where x is 0, which would be on the y-axis. Now I also need a second hole, so it could be any factor. So I'm just going to make one up, x plus 4 over x plus 4. So now that would create a second hole. And so this is a possible function. F of x equals x times x plus 4 over x times x minus 2 times x plus 4.